In today's lesson, I'm going to be walking you through problems on exponential sequence. So if what you need is the arithmetical progression, that is the linear sequence, the link for that is in the description below. So before we begin, make sure you subscribe to this channel. What is a geometrical progression? So you should know that in a geometrical progression, the ratio of the term and the term preceding that term is always a constant, which you know as the common ratio. Just like the relationship between terms in the arithmetical progression is called the common difference. What do we mean by that? Let's say we have this sequence 6, 12, 24, 48. I said if we should pick a term and the term preceding it, their ratio is a constant. So let's pick, we have our first term here, we have our second term, we have our third term, we have our fourth term here. So let's pick the fourth term, 48, and our second term, our third term, 24. So their ratio is 2. Let's pick this second term and the first term, which is also a. We have 12/6. The ratio is 2. Let's pick the third term and the second term. We have 24 and 12. Their ratio is also 2. So we see that it is a constant throughout. So this sequence here is a geometrical progression. So if you have a sequence and you are told to find a particular missing term in that sequence, the formula for that is Tn equal to Arn minus 1, where Tn is that missing term, A is the first term, R is the common ratio, and N is that missing term minus 1. So how do we come about this formula? Let me show you here. Looking at this sequence, we have its first term as A equal to 6. This is its first term. We have its second term as the first term multiplied by the common ratio, and this is 12. So this is also A multiplied by R. We have the third term as the second term, which is 12 multiplied by 2. This is 24. So this is the second term multiplied by R. Don't forget our second term is now AR, so we can just substitute that here. So we have AR multiplied by R. Now we have AR squared. So we have AR squared. Now what about our third term? Our fourth term. Our fourth term is our third term multiplied by the common ratio. So this is also AR squared multiplied by R. So here we have AR cubed. So if you look closely at these values, here we have AR, here we have AR squared, here we have AR cubed. You see that to get a missing term, we have to pick its first term. We have A here, multiplied by its common ratio, which is also here, raised to the power of that term minus 1. For the second term, we have 3 minus 1. We have 2 at its power. For the second term, we have 2 minus 1. We have 1 as its power. For the fourth term here, we have 4 minus 1. We have 3 at its power. So we have n minus 1. So this is the formula to get the nth term of a geometrical progression. Let's put this into practice. Our first question says find the eighth term of an exponential sequence whose first term is 3 and whose common ratio is 2. So let's list out the values we have here. We have the first term as 3. We have the common ratio as 2. And we are to find its eighth term. So according to the formula we have, to get the nth term, we have AR n minus 1. So here we have the eighth term which we are told to find. The first term as 3 multiplied by r, which is 2, and n minus 1, that is 8 minus 1, which is 7. So this is 3 multiplied by 2 raised to the power of 7 is 2 raised to the power of 7 is 128. So 128 multiplied by 3, we have 384. So this is the eighth thing. So you should know that this is not 6 raised to the power of 7. No, you don't solve that way. This is the way to do it. So let's step this up a little bit. Our second question says the fifth term of a GP is 96. Another name for the short form of geometrical progression is GP. So the fifth term of a GP is 96, and its first term, find its first term if its common ratio is 2. So we are told to find the first term of this GP if its common ratio is 2. So let's list out what we have. We have the fifth term as 96. We have the first term as missing, and we have the common ratio r as 2. So we are told to find the first term according to the formula we have. So we have the fifth term is 96. The fifth term is 96. So let's write out the formula for the fifth term. We have the fifth term is equal to first term multiplied by the common ratio raised to the power of 5 minus 1. 5 minus 1. 5 minus 1. 5 minus 1 is 4. So we have 4. So, but we have the term 5 as 96. So we can just substitute that. We have 96 equal to the first term is missing multiplied by the common ratio, which is 2 raised to the power of 4. So this is equal to 96. 96 is equal to 2 raised to the power of 4 is 16. That should be 16. Yes, 16. 2 raised to the power of 4 is 16. So we have 16a. So we can divide both sides, the left hand side and the right hand side, by 16 to get a. So 96 divided by 16 is 6. So we have a is equal to 96 over 16. A is equal to 6. So we have the first term of this geometrical progression as 6. Let's take another question. So this one is a little bit tougher than the first two we have solved. So if you find my lesson interesting, do well to subscribe. And for the lesson on arithmetical progression, you can check the description below. You should get the link for that there. So our third question says the second term of an exponential sequence is 35, and the fourth term is 875. Find A, the first term, and B, the fifth term. So if you look at this question, you can see that we don't have the first term, we don't have the common ratio, so we have to compare two different terms. Let's list out what we have so we can see them. So we have the second term of the exponential sequence is 35, and this is the same thing as AR. You should know how we came about that. And the fourth term is 875, and this is also AR 4 minus 1, that is 3. So we are told to find A, first term. We are told to find the fifth term. So we're told to find the first term, yes. We're not told to find the second term also, yes. But that doesn't mean you shouldn't find this common ratio. The first term and the common ratio is needed. So we have to get the first term and the common ratio. So let's erase this. This is not necessary. So we have two equations here. Equation 1, we have equation 2. So from equation 1, if we should look closely at equation 1, we see that we can just make one of the variable the subject of the formula. Let's make A the subject of the formula. From equation 1, we have 35 is equal to AR. So we can make A the subject of the formula by dividing both sides by R. So we have A is equal to 35 over R. So we can substitute this value for A in equation 2. So from equation 2, we would have 875 is equal to, since A is now 35 over R, multiplied by R cubed. So here we can solve this. We have one R here, we have R times R times R times R here. So we can just get rid of one of the R here. So this is R times R times R. So we can just get rid of one. So we have R squared. So from here, we have 875 is equal to 35 R squared. Since we are looking for R, we can divide both sides by 35. So we have 875 divided by 35. That should be 25 divided by, yes, we have 25. So we have 25 is equal to R squared. So to get R, since this is R squared, the opposite of the square function is the square root. So we can just take the square root of both sides. So we have R equal to square root of 25, which is 5. So now we have our common ratio as 5. So we can get the first term from here. So we have 35 over R. So this is 35 over 5. And that is 7. So we have our first term as 7 and our common ratio as 5. So we have solved the first part of the question. The second part of the question says find the fifth term. So the fifth term is equal to A times R raised to power 4, and this is 7 times 5 raised to power 4. 5 raised to the power of 4 is 625. 625 multiplied by 7. We have 4,375. So we have 4,375. So this is our fifth term. So with the explanation I've just made, up now you can solve questions on exponential sequence. So do well to subscribe. I'll catch you in the next video. Take care.